I'm Paul Palonsky. I'm the Chief Revenue Officer at Solidigm. A little bit about myself. I was 31 years with SK Hynix. Some of you might have heard of SK Hynix as head of U.S. sales. About 2 years ago, as we were going through the integration process with the Intel Network Storage, a NAND storage group that Hynix purchased, I came over to Solidigm and ran U.S. and European sales. And then beginning of this year, I took over global sales. So I'm head of the global sales group. Scott Shadley will introduce himself.
Hi everybody, if you don't already know me, Scott Shadley. I joined Solidigm shortly after day one, so I'm not ever been part of Intel or the Hynix side. I come from a history at Micron and a few other startups where I've met quite a few of you from those startups, including Mr. Miller and Mr. Stammers and all. I currently sit in the marketing side, and my title, as you can see, is quite long. I got paid by the character. My salary went up every character. So I'm the Leadership Narrative and Evangelist. I'm the guy that gets to go out on the road and talk to a lot of you on a regular basis. To Fred's point, I'm very seen and vocal in the industry. So looking forward to talking to you guys today and sharing a little more about who and what we are. So
great. All right, so I wanted to start off talking about AI and get your perspective on it. Yeah, like I said, I come from Hynix. Hynix has become famous now for being the leader in HBM memory. Company's made some good profits from that product portfolio, and we work very closely with NVIDIA, AMD, Broadcom, and others, enabling this GPU technology. And for a long time, that's what the business was about. It was about the DRAM, which was good because 31 years with Hynix, I was selling DRAM. But the storage seemed to start, and then it stopped, and it seemed to start, and then it stopped. And that was kind of training. Solid state drives was important, but hard drives worked there as well. Now we're at the point where people are monetizing all this money they've given to Hynix and to NVIDIA on the training, and they're working on the inferencing side. And what we found over literally the last 4 months is the CSPs, the core CSPs in the US and China, grossly underestimated the amount of storage they need to do inferencing. And that hard drive simply is not fast enough, doesn't have enough bandwidth, the latency is too long for effective inference solutions. So all of a sudden, fortunately, I moved from DRAM, which there was nothing left to sell, it sold itself, HBM, everyone wants it, to solid state disk drive, which I think is going to be the new area of memory growth. So I wanted to get your opinion. What do you think of this AI revolution? Is it a flash in the pan? Is it a 3-year wave, a 5-year wave, or is this changing the way semiconductors and the way we live? So let's open it up to that.
Well, anybody can answer that question precisely. Should you bank on being a millionaire?
crystal ball?
So a millionaire, I would say, is underestimating it, because you have billionaires that are betting their entire fortunes, like Larry Ellison with Oracle. The amount of debt Oracle has taken on to fund their AI infrastructure is astounding. And Larry, at the age of 80, is coming back to monitor the company, run the company, because he believes in it. Still, I have come.
That's too much like magic to me. I mean, the AI promises sound a little bit like you don't have to know anything. Just throw something at this machine, and you'll come back with the right answer really quickly. And that's a very, very dodgy sales message.
True, I agree with that, but it'll come back with an answer, and that answer will be iterative. So
but it doesn't have an answer, but it may come back with the wrong answer, or an answer that you interpret wrongly, or...
Just like journalists.
I'm not a journalist.
Go ahead, I'm sorry.
Just because I'm not afraid of making myself look stupid, I'll throw you in personally. I'm naturally skeptical, but I suspect that there is, I mean, if you watch those, it's going to destroy YouTube Shorts and Instagrams. I saw a comment posted the other day, because all those lovely cat and dog videos that you see on Instagram are now AI. They're just not believable. You see a video of a cat doing something charming, and it's if the first comment you read is don't believe it, for instance, AI. But the reason why I mention that is because it shows how much power, what these things are capable of, what these LLMs are capable of. And that's not even whatever it is, AI is capable.
Yeah.
My guess is that AI will prove to be like the internet. It would take years, but it could well be transformational. The internet has been transformational.
Yeah, I'll go all in. The latest version of the latest new electricity.
Yeah. So I liken AI to the fourth industrial revolution. So we had the steam engine in the first industrial revolution. I think AI is as significant to the way we're going to live and the way industry is going to evolve to that steam engine. But it's insidious and it's going to be pervasive. And it's going to be in every workload and you're not even going to know it's there.
I agree with you, it's going to change the world. But if the heat gets out of control, it raises the ocean level by about 6 feet. We might find that operating the world with New York underwater is a bit tricky. So it could change the world in a way we don't expect.
Well, no one says technology is a one-way street for goodness. The internal combustion engine changed the way we live our lives. It also created a lot of pollution, climate change. Everything has good and bad. AI is no different. But my premise is AI is with us long-term, that the growth in data centers are only going to be limited by the amount of electricity and the amount of money you could throw at it. And companies are throwing tremendous amounts of money at AI. Where OpenAI is getting this funding, sovereign governments, at least in the United States, we could print the money as long as you guys accept it for the time being. But, there's vast amounts of money going into AI. So when customers say to me, oh, prices are going up, and they are. Prices are going up, I'll wait it out, it's a flash in the pan, it's going to change, memory cycle, 3 months, and prices will crash. I think they're missing it. There's so much demand that the industry can't source it, especially in NAND flash. So,
Paul, let me come back to you with this.
Yeah, sure.
You're right, there's a lot of demand, there's a lot of money being thrown at it. Where are the reports of real ROI?
look at Microsoft's earnings.
I'm sorry?
Look at Microsoft's
So
earnings.
one, okay, give me another one.
But they were the first one.
Okay, there's hundreds of millions of
Look at the growth of CoreWeave. Look at the growth of Oracle. Look at the growth of companies that have been leaders in AI.
Oracle's investment in trying to sell AI. Where are their customers' ROI? Exactly.
Okay.
That's the point I'm trying to make, right? Which is that
Back up then, Ian.
wow, that's a first. That's a first.
There are a couple of reports, one by MIT and one by Gartner, saying that businesses generally, most AI projects fail, and they're widely cited. When do you think those two organisations will start putting out reports saying businesses are getting ROI from AI projects?
I think it's starting. And like I said, it's quiet, it's pervasive, it's infecting every workload. So you can't just say, look at the ROI for this, what cloud service provider, because down the road, they're signing up new customers. If you look at guys that didn't invest so much in AI for their infrastructure as a service stack versus the guys that did, the ones that are growing fastest today, bringing on new customers, new workloads, new business, are the ones that invested in AI. And the other ones are having to catch up. AI is just disruptive. For example, at Google, they're having to incorporate more AI, otherwise they lose the search empire. So
we have seen the film already with the cloud, 10 years ago, if we were not in the cloud, you will die.
Yeah.
Today with AI, it's the same film. If you don't have AI, you will die. That's always the same way. That IT industry try to sell something. We are fed up of that. There is no value, there is no ROI on this kind of project for the moment. There is only automation and gain of productivity. That's all.
All right.
That's garbage.
Yeah.
It's another hype cycle.
Yes.
And yet on-premise demand has flattened out, and infrastructure as a service has continued to grow and prosper. So these things,
I take issue with that.
okay,
On-prem investment is actually going up.
not as fast as cloud.
Slightly below cloud, so cloud is slightly more attractive, but there's a lot of workloads being repatriated out of cloud because over time cloud costs have gone up, even with the enhanced volume of adoption. I've been in plenty of dinners with CIOs talking to AWS and going, we can see your revenue, we can see your margins, you're making software margins on an infrastructure service, and why are our bills going up when you promised us they'd go down? So they're wanting to come out.
Sure.
So
But yet I look at HPE, Dell, and Lenovo's revenues, and they're going up, but they're not dramatically going up.
yeah,
Not like Microsoft, not like Google, not like Oracle. So
Oracles are not going up.
Oracle will be going
Oracles
up.
are pretty much flat, a little bit up.
Yeah,
but
as
not
Oracle
really.
brings on Starlink and brings on
Oracle
OpenAI,
take on
they're going.
OpenAI is going to double their revenue with one customer.
Yeah.
They don't have the capital to deliver it, and they don't have the skills and the people to build it. So, because what they've committed to is bigger than Microsoft's current data centers that are built for Azure. So,
Sure.
you just got to look at it from first principles.
So we're not going to agree on whether it's a flash in the pan. We're going to have to rule that. We're going to have to rule that it's not going away. Some of us are right. Probably the answer is in the middle here. But
I'll just flip it round again and say,
yeah.
where do you think the vast majority of AI spend is coming from?
so our data says it's coming from the cloud. So this chart here says the cloud is growing dramatically faster than enterprise on-prem. So that's the data that we're looking at. We believe that this AI spend is going to be pervasive. This is going to be a long cycle because
This is based on which data?
So this data is run by a market analyst team that we have that talks to the Gartners, the IDCs, and everyone else.
So this is your internal
customers
team?
and things like that. We talk to our customers, we talk to the other analysts
Yeah.
in the market.
So
and
It's
pull
not,
it
this
back.
is your internal team, right?
this
Yes.
is
Your
this
internal.
is Scott's data.
Yeah, this-
Okay, just want to understand.
yeah. So it's just like we put the line in the sand like everyone else does. So Gartner has his way of saying it, IDC has their way of saying it. We muddle it, if you will, with customer feedback, and we put together the best foot forward we can from a forecast perspective, just like everybody else does.
Is that service spend?
Yeah, can you read out the chart is really interesting. Can you read out the, sorry.
Go ahead.
Can you read out the scale and the labels?
Yeah, so this is last year, forecasted for this year, next year, and 27.
Yep.
And it starts at the $50 million mark and goes up to the $450 billion mark.
And
Sorry,
the light
billion
pink
dollar.
is what, cloud service revenues?
The line represents the mix of OEM versus white box spend.
Sorry. So-
The Dell selling it versus a Supermicro reselling it and things like that.
Yeah, what's the pink and what's the purple?
So
maroon
pink is the cloud spend versus traditional enterprise.
So our GPU accelerated service included in these numbers. What's that going to
Not specifically, no. It's a conglomerate of all server, well, yes and no, because it's all servers that are being bought for the data
Right
center.
now, almost all GPU accelerated investment is in the cloud.
Right.
And it's driven by AI, which fundamentally shifts some of the balance. But if you look at enterprise, it's a different story.
Right. That's exactly kind of the point is AI is definitely driven by the cloud first. Enterprise always catches up at some point, so there is going to be growth. Enterprise is still going up, and we'll see the hockey stick for it once things settle down, right? So that's why, to his point, it's not going to be going away. It's just going to continue to transition over time.
Are these both GPU and x86 servers?
These are any server a data center is purchasing based on all that feedback. So GPU-based, storage-based, CPU-based, doesn't matter. It's a conglomerate of the entire industry.
Yeah, the simple answer is yes.
Yeah.
So I agree with those numbers of GPU accelerators
Yeah.
in the cloud.
Yes.
You announced 122 terabytes of disk, SSD disk. What is your roadmap to sustain that in capacity? Because it's great to have disk, but to sustain all this volume and capacity in the data center, what is your roadmap further than the 122 terabytes?
So we have a 245 coming out next year, but I think the more important question there is, where is the capacity coming to build all these 122 and 245 terabyte drives. And that capacity is going to take time to develop, because for NAND flash, there's not a lot of clean room space out there. Hynix took down some NAND because NAND was losing money a year and a half ago. Hynix took down some NAND. First time they moved DRAM from Icheon to Chungju. Chungju was their dedicated NAND facility that they picked up during the LG merger back in 2000. First time they took half a fab down, changed it over to HBM. That's not switching back. Hynix is going to build a new fab on their new campus. It's a DRAM fab. Micron is building up.
Can you remind us what you mean by HBO?
Sorry?
HBO?
HBM, high bandwidth memory for GPU servers.
Thank you.
Yeah, Micron's building a new DRAM fab in Boise, not a NAND fab yet. The only one that has clean room space right now in the industry is Kyosha, and Solidigm has some clean room space in Dalian, China. So there's not a lot of clean room space for NAND. It costs a couple of billion, $2-3 billion to build a fab. Takes about 1.5 to 2 years just to build the building. Then you got to buy the equipment. So we're not going to have substantial amounts of new greenfield NAND production for about 3 years.
How much AI do you utilize to go with that development that you have to do? So how much do you utilize yourself in AI?
So we're starting to
make that happen?
Within Solidigm, we have a dedicated project that is at the CIO level and working with our CEO to bring AI into the company. We're looking at incorporating AI into our firmware code writing. So we're looking for efficiencies to propel our roadmap forward to get a competitive advantage by investing in AI.
Yeah, we actually held a demo day inside the company where teams inside the company found ways to use AI to make things more effective.
Waiting for offensive.
AI is here to stay. Because of all the cat videos, it does the best cat videos. But more seriously, is the fact that every time you go on the web, you see AI, you see enhanced pictures that would have been a bit scrappy a year or so ago, and now pixel perfect because of AI. How much is that influencing people's subliminal perception that AI is going to take over?
Yeah, that one's interesting, and one of the reasons we put the question up was because AI is the big topic we wanted to talk about it. One thing that nobody's really mentioned and we're going to spend the next hour plus talking to you about is how to enable all of that, right? Because we know what NVIDIA is doing with the GPUs, we know what everybody else is doing on that front, but the storage, or the storage guy, is what tends to be always overlooked, and there's a lot of things that we're doing to make sure whatever you need from a data access perspective is there with our storage products. So I love the idea of talking more about the cat video, but I don't own the model. I will host the model on my drive absolutely all day long. So.
All right, so enough about AI. So we've come to a consensus in the room. It's either nothing or it's everything. So we've got that consensus. Let's talk about then who Solidigm is. All right? Solidym's built on 40 years of experience with NAND and NOR flash. Started off with Intel's NAND storage group. Intel made some drives using a NOR drive. Our goal is to become the #1 enterprise SSD company in the world. Currently, Samsung has that position. Our goal is to overthrow them together with SK Hynix combined. SK Hynix already in dollars has exceeded Samsung in revenue over the last several quarters with their HBM memory and DDR5 memory being vastly superior. We now have that same goal, at least by a revenue point of view, to be the top company in the world.
Did you say bigger than SK Hynix?
No, I said SK Hynix is bigger than Samsung
Yeah, you
in
said you wouldn't be
revenue
bigger than
over the last
Samsung in combination with
in
SK
combination with SK Hynix.
What do you mean by in combination? You buying
We're
flash?
part of SK Hynix. SK Hynix, we're 100% owned subsidiary of SK Hynix.
Oh, okay.
So we
And
go to
how many
market. We go to market collaboratively. They have some products that were pre-existing of Solidigm that are enterprise SSD market products. They have what, about 12% market share. We have somewhere in the mid-20s. So combined, we're about 30-something. Samsung's 40-something. So they're in our sights. and our goal is to be the #1 enterprise SSD company as a consolidated entity with our parent company.
And if you look to other markets for flash, for instance, the automotive market is also a big consumer of flash memory. How much of the stuff you do is car automotive, and how much of the stuff you do is NAND for computing?
So for Solidigm,
Yeah.
within that,
For
within,
SK as a group.
yeah, for Solidigm alone, all the NAND we consume goes into enterprise SSD. 100%. We killed off our client drives about a year and a half ago. Hynix is more diversified. So of course they're in smartphones, they're in automotive, they're in consumer electronics, they're in every space. You can look at the analysts to see Hynix's capacity compared to Kyosha and Kyosha SanDisk combined from those fabs, and from Samsung. Samsung's #1, Kyosha #2, Hynix close #3. Yep. So that's our goal. If we look here, this is where we've been and where we're going. So like I said, we started off with NOR flash drives a long time ago, 1990 something. In 2018, we brought out the first 4-bit per cell SSD. So up until that time, everything was 3 bits per cell or 2 bits per cell, MLC or TLC. We brought out the first QLC drive. And then since Hynix bought Solidigm at the end of 2021, we brought out the world's highest capacity QLC solid-state disk drives. We were first to market with a 61 terabyte drive, and now first to market and the only supplier commercially providing the 122 terabyte drive.
Are you doing any development on PLC yet or not yet?
So PLC is incorporated into our designs. So every one of our floating gate chips can support both anything from SLC to PLC modes. We have not commercialized PLC yet. There's some TCO trade-offs there that it's going to take some time to resolve, but we are talking, with customers about how they would use PLC. It's going to be slower. It's going to have a little bit higher power because of the right amplification power is higher. So there's some trade-offs there.
Maybe for long-term or cold storage, perhaps.
Yeah, for longer-term cold storage. But right now, I'm going to show you where the sweet spot is. It's in this new tier of warmer storage. Okay. So as I mentioned, Solidigm is a 100% subsidiary of SK Hynix, and our co-CEOs reflect that. So I'm over here. Good picture of me, by the way. Jinsu Kang is from SK Hynix. So he was from the technology side, the business side, the AI side, and he is our acting co-CEO from the SK Hynix side. And Xin Gao is the acting co-CEO from the Solidigm Intel side, and he is also our head of data center engineering. So he wears 2 hats. He's in charge of all our R&D and development and acting co-CEO, and then Jinsu is the other acting CEO. We're looking at finding a permanent CEO, and the board of directors in SK Hynix is working on that. I would anticipate somewhere in the next couple of quarters we'll have made that decision. In the meantime, these 2 gentlemen are running our company along with the support of our senior staff. Okay. So Solidigm provides our customers with a complete end-to-end solution of enterprise solid-state disk drives. We do everything from SATA drives, which still have a tremendous amount of demand, to high-capacity drives, such as the 122 terabyte. And we also have the highest performance Gen 5 drive in the 2, 4, 8, and 15 terabyte ranges that are direct attached to those NVIDIA GPUs. They are on the RVL for NVIDIA, on the GB200 and the GB300, and we just introduced them kind of in the middle of this year, and they're already becoming one of our hottest SKUs. Next year we'll be completely sold out, already sold out on those drives, and I have people texting me, they're going to pay me a premium if I can move out allocation. So this drive is one of our hottest drives, along with the high capacity drive, which over the last 3 months, our demand quadrupled, quintupled. It's just been amazing, the amount of CSPs that came to us all at the same time with the same theme. We grossly underestimated our requirements for storage. We want to buy 5 times, 10 times the amount of storage from you.
So why did they grossly underestimate?
Because of inferencing, the inferencing solution.
Which aspects?
Excuse me?
They just didn't realise, they didn't understand how quickly inference.
They thought they could use hard drives. Hard drives don't have the performance, they're not available.
You mean disk drives?
They were using hard drives for training, and they said, hey, we got this fleet of hard drives, we could use it for inferencing, and then the latency on the drives and the performance wasn't there, and the amount of data these inference models are churning out from the large language models, just overwhelmed their storage. So overnight.
Are we talking about things like KV caching and the limitations of HBM when it comes to large context windows?
HBM is running the computational side. Right. This is the computational side, then it's creating all this data, and the data has to be stored somewhere. And the inference solutions that are monetizing and getting to customers, they need to have a higher bandwidth storage solution.
What is it in inferencing that's creating the data?
So I actually have, if you don't mind waiting, because we can't jump around real easy in this show. I have a few slides that explain what we're talking about in more detail.
My impression was that training is where the ballooning of data.
But it's both. That's the unique aspect of it. Yeah. So I'll show you a data flow a little later on that shows you where all the points are and what kind of data sizes are being generated.
So Paul, since you're a money guy, right? So having somebody pay you a premium is not surprising. We've seen this before. We've seen this movie many, many times where the capacity shortage. So if somebody's going to pay you extra, come back to the ROI conversation, which means that the cost of delivering AI solution goes up. Therefore, the ROI comes back, reduces, even if you are getting an ROI on it, right? So how do you come back and reconcile that?
So literally overnight, about 3 months ago, the industry found they needed 100 exabytes more NAND storage.
Sure.
Okay, that's more NAND storage than Solidigm sold with 20 some odd % market share. More NAND storage than we've sold the entire 2025. Okay, that demand was created, and it's been split up with ourselves and our competitors. So that demand is being satisfied, but it's created a shortage elsewhere. On this PS1010 device, we're about 45% able to meet customers' requests. So yes, prices are going to go up. There is elasticity demand. Demand is going to be destroyed. When demand is destroyed by 50%, I'll start worrying. Then prices will come down, or maybe DRAM availability will come up first. DRAM prices will come down. That'll pump more money in the ecosystem, and we'll keep selling at a nice ASP.
So is this going to impact the ability for enterprises to do this on their own premises? Because they're not going to be able to get the infrastructure to run AI.
If you have enough AI demand that you can amortize the high cost of the machine, it makes sense. I think a lot of people don't have that demand today, so therefore cloud is where a lot of the AI is happening.
Because the cloud pull ahead. Because the cloud providers are placing bigger orders, they're going to get them. Their orders are going to be fulfilled first. So I think what Simon's saying, it seems to me, is that the enterprises are going to find it very expensive to buy the flash drives they need to do AI. So they're going to have to do it in the cloud, and that's because the cloud providers grabbed all the flash drives.
Not only that, there won't be availability in the short term. The cloud guys are taking up a lot of our capacity, a lot of our competitors' capacity.
That also poses a new problem, which is now you get all this data into the cloud and manage the data between on-premises and in the cloud, which again drives up the cost of management, which again drives up the cost of operational aspects. So we have to, I don't want to keep going with this conversation. My point is simply that this issue we've got right now with AI, with all this demand and all this lack of supply, is going to create a very interesting set of dynamics in terms of economic benefit. Let's throw away the word TCO and ROI and all those three-word acronyms, right? What the economic benefit we're actually going to see at the end. Because for most enterprises, for a large part playing with AI, they still don't know what the hell they're playing with.
Okay.
It's still a science experiment.
Oh, you're going to end up throwing a lot of money at it until money runs out, it runs dry, and then still
And they'll still see nothing from it.
right?
Yeah.
Right.
Yeah.
And you get to the same cycle where eventually it goes down, and then you start seeing AI as a future, which is we have AI which helps us solve a problem, and not like
So I think ultimately, markets over a long period of times are efficient. And these problems will work themselves out. Pricing will work themselves out. But if you look at just the basic laws of economics, supply and demand, over the next 3 to 4 years in the NAND space, there's more demand than supply. And supply is very, very challenging to come on board, even through increasing layer count. The NAND industry can only grow bits by about 15 to 18%. The demand is totally outstripping that.
Well,
Same thing on the DRAM side.
Yeah, no, I think we're all agreed on that. The conversation we're always trying to figure out in our head is how do enterprises and how do people make money out of this?
Okay. So,
which is not your concern.
No, it's not my conversation later. Yeah, exactly.
Because you're getting the money.
That's something the big
So, going back to being the number one in enterprise SSD, we're going to work with our customers to provide the solutions they need. And the technology, the use of the technology will determine what those needs are. And whether those needs are to move from Gen 4 to Gen 5 to Gen 6, we think it's more along the lines of higher capacity to meet this problem, which is that data is warming up. So what I described in inferencing, and Scott can get in more detail as to the why, because I'm the money guy, he's more the technology guy. What we're finding is that this colder layer is where HDD plays, will continue to play, and does a very good job from a cost of performance area. But they're not adding capacity either. So WD and Seagate are not building new fabs. Okay? They're going to increase the capacity of their drive. Those drives get slower as the capacity goes up. There are more heads, more platters, more seek time, slower performance. That's exactly the opposite of what inferencing requires. So they're going to be relegated to this vast pool of cold data, and they're going to do just fine. And that's why they're not investing, because they know they don't have the right solution to hit this pool of warmer data. And this is a new pool of data. So it was, with the PS1010, the fastest performing Gen 5 drive out there, that's where this was. On the direct attach with the GPU, that's where that thing played. And it was great, except there wasn't a lot of volume, and we didn't make a lot of money because we had the best thing since sliced bread, but there was limited demand for it, and there were only 4 terabyte, maybe 8 terabyte, and next year maybe 15 terabyte. But it just wasn't enough to take all the capacity we're building. But now we're seeing this tier here, where this is a new tier that requires 60 terabyte, 122 terabyte, 244 terabyte. And that, a 122 terabyte drive, not the Lego one that we gave you, the real one wafer, one drive. Okay? Imagine that. One silicon wafer, one drive. Okay?
You might as well put it on a turntable and spin it for a hard drive.
We actually had that, we were planning that for a demo at a trade show, to be honest, just to have poke it hard drives, yeah. But, so this is a live, a true to live drive. It's dead, you can't plug it in, it won't work, so don't try to steal it. But it gives you the weight, the feel, and the idea of what it takes to put 122 terabytes in a deck of cards, basically. So.
Are you going to approach a limit on the node size like we did when we were on 2-dimensional flash, and then?
Eventually we will. We have at least two or three more generations to go on floating gate. On Charge Trap, we have more than that.
Yeah.
Okay.
Do you have an estimate of the time to write a full disk through the interface?
That's workload dependent. You give me large block sequential writes and I can fill it in a couple hours.
Max write rate.
Takes about an hour and a half to 2 hours.
To fill up the entire drive through the native interface.
Yep.
Yeah, that's still good because typically a hard drive is terrible for that piece.
That's yep, and we can talk about that some more as well, for sure.
Yeah.
So hour and a half, okay, good.
So if you want to buy one of these, I'm the only one that,
$30,000?
they're kind of expensive.
Don't we all get a demo? Say come and play this?
I gave you all your own version of 122 terabyte drive. You even get to build it yourself. So.
Yeah.
You want to put a little SSD in it or something. Just to...
With some packed firmware to make it look like something.
If you want to buy one of these, Solidym's the only one that can sell it to you. Our competitors have samples out there that haven't gone to mass production yet. So
how much is it, please? Since you raised it.
It's quite a bit.
And how much is it tomorrow? How many do you want?
Surely you should just warehouse these for
So I'm not going to tell you the list price of that drive, because I'd blush, but I am going to tell you how much 122 terabytes are. So most of the room remembers the 1990s and went to the movies, and there were actually movie theaters, and they made a lot of movies. Well, one of these drives can hold 2.6 times in 4K format the number of movies that were made in the entire decade of the 1990s. That's how much storage is in a 122 terabyte drive. And yet it's not enough. So we're going to build a 244, and we'll build the one bigger than that when the demand is there.
There's an awful lot of data that seems to be waste. How much of it is actually ephemeral? How much of it is actually important? How much of it is just cat videos?
A lot of these drives are paired with very unique software solutions from customers. Yeah. So there's deduplication, there's all that compression, all that going on, and yet it's not enough storage.
And how hot do they get? I mean, that little drive just showed us.
He has some of the specs.
Yeah.
Again,
from a thermal perspective, it's not any hotter than any other SSD, which gets warm to touch when you have it fired up.
All right. I got a little bit long-winded.
Sorry, Paul. Anthony has a question.
Yeah.
I'm sorry.
I'm just wondering how you fit this capacity in that form factor, because obviously you know that Pure Storage sell capacity of this order in terms of capacity, but he wouldn't call it a commercial product.
Thank you, Anthony. You set up this slide.
Your answer.
What they say is they can fit the capacity in there because they're not having all the onboard cache, etc., and the things that go along with the actual.
It's called smoke and mirrors to sell software.
So Pure's solution relies on Pure's software. Our drive is a standalone drive. So they have a bigger drive, but we have a standalone drive that you don't have to buy their software suite to use. Okay? We do it because
how do you get capacity?
we do it because we have advanced packaging. So we have the only floating gate technology still in production for NAND, which is really good for QLC, and we have advanced packaging leadership that allows us to make denser drives in the same space as our competitor. So we're able to utilize the real estate in that U.2 form factor or E1.L form factor better than our competitors can do. And that's how come we were first at 122. They're having to do it a little bit differently. They'll get there, and then we'll get to 244. That's our plan, at least.
To your point, Pure has a custom form factor and a custom software. So it's 100% custom if you would like to go that path, where this is plug and play in the industry. We set the definition of the form factors. We continue to drive the form factors.
So it would be really interesting to, maybe not today, but a conversation, maybe sometime about the way you handle all of these, distributed flash, translation layer and so on. How you manage that, and especially when you reach this scale, when you have, almost what we're talking about, half an exabyte on the drive, right? Or things that it's, we're talking terabyte. So you have a quarter of a petabyte basically on one single drive, right? So it raises questions about the way you design systems, the way you fold domains and so on. So
exactly.
It's interesting.
Yeah.
Happy to follow up on that, but the 1998 start date to now, we've learned a lot of how to do firmware management on these devices.
And we also have software to help customers with that. Interesting also is Solidigm is the only NAND enterprise SSD company going to market with multiple types of media. So we have the floating gate media produced in Dalian, China. We have the charge trap media from SK Hynix produced in Cheongju, Korea. And we're looking at other medias as we go forward to continue to grow the company. But we're the only company that our designs are media agnostic and that we could drop different media sets into our drives.
Does it mean I could just plug this in any old server, if somebody's got the right socket in it, I could just plug one of these drives into any old server I have at the moment?
Yep. As long as the server supports an NVMe interface, this plugs and plays.
Yeah.
All right, Sales eChart, we provide the full product portfolio for our customers. That's our goal, to service our customers, to help grow their needs, and to find the right solutions that make a TCO sense for the business. So the last slide I'll present, then I'm going to turn it over to Scott, is just some facts about Solidigm. 4 in 5 of the exabytes sold as QLC, they're Solidigm exabytes. 1 in 2 of a 30 to 60 terabyte drive is Solidigm. If it's just 60 terabyte, it's more than 1 in 2. And 100%, like I said, of the 122s, well, that's mine as well. So I think I'm leaving in a good place here, and Scott will take over and tell you a little bit more about the technology. Thank you.
Yeah, and so just from that perspective, one of the biggest things that we focus on from a perspective of our technology is we spent a whole bunch of time at the beginning talking about AI, but it's not just AI that's important to our customers, right? The enterprise, the cloud guys. So what we've done here is the portfolio we just showed you kind of maps to all the different workloads we expect people to put on the given drive, whether it's the 122 or the PS1010. They have reasons why they all exist. We have a whole catalog for that purpose. But we do have the AI workloads tied to them, but they also fit into the rest of the portfolio, if you will, as far as pick a workload and we can help you design a solution with the right drive. So yeah, would I want to sell you the big drive for the highest price? But does that really solve the problem? And to the point of availability, some of the big drives are definitely having some scarcity, but some of the traditional enterprise market space, we can still plug and play with that to make sure that we address the workloads.
Do these last as long or longer than competing?
So this drive right here, we guarantee that you cannot wear it out in the 5 years you have a warranty on it. That's how the endurance capabilities are. Because there's so much media, it's almost impossible to overwrite it, because NAND had the problem way back when where everybody's worried it's going to wear out really fast because it's only got so many cycles. We've got so many cycles of accumulated NAND in here that the impact makes them last longer. Our failure rates are quality of the product. Also, we have data on that shows that we're best in class. We have the lowest failure rates, we have the highest quality rates.
Okay, but even so, if it's the most expensive drive available at the moment, 5 years might not seem very long.
Well, no, and then that's getting back to TCO models, what makes sense. We could have ROI discussions all day long about it. It's a matter of solving the need with the right product and making sure you do it. So someone asked, how do we cram 122 in it? This drive exploded out, showing you exactly how we put everything in the system.
And what Scott was saying is, if you write, erase constantly, that's all you do. You're writing and erasing the drive, it'll take you 5 years to wear the drive out. So, no one runs a workload like that.
Yeah, so, Scott, you might be addressing this later on. One of the challenges for QLC is the fact that you have to put so much extra NAND in it to deal with the right issues, which made its ability to be accepted versus TLC from a cost perspective delayed. How do you address that? And if you're going to address it later, that's fine. I just want to throw that.
Well, no, I mean, it's a solid point. So the legal department gets in the way when I say 122.88, because people ask how much is actually on the drive, right? That's the user available space.
Yes.
TLC drives, QLC drives all have over-provisioning. Yeah. And in the case of this drive, it's no more over-provisioning than any of their products. You're talking 128 formatted down to 122.88.
128 down to 122.
So a 16 terabyte raw drive is 15.36 relative.
So you only got 6 terabytes, something like 8 terabytes over capacity.
Mm-hmm.
So that QLC will last for 5 years.
It'll outlast 5 years. We just warranty it.
Yeah,
for
sorry,
5
you're
years.
warranted for 5 years. Okay, whatever.
So So to Max's point, even though he left, the controller architecture is our in-house controller as well as our firmware that has evolved over all of the generations of NAND. You can see we have an amazing amount of NAND placements. It's the smallest NAND package on the market. So JEDEC defines some package form factors, but since we're not selling these on the open market, we can put them in whatever form factor we want. So we can shrink the die size and fit more into the drive as well. So I can stack more in a smaller package than someone like Pure who's buying off the street. So they get the standard form factor, which is larger. We have the power backup that everybody expects to have. So you do have your capacitors that are built into the drive. And then, of course, the end-to-end data protection. So I've got kind of the green around it saying that we will guarantee as soon as I say I've got your data, I've got it. And we'll make sure that it doesn't go anywhere. So we have the proper caching techniques and everything, because that's one thing that makes an enterprise sole focus for us, is we think beyond just plugging it in and using it, and I get a blue screen, I restart, and I lost some data. We don't let that happen. In fact, we spend a significant amount of time with our customers on what happens if there's a failure, and how to handle that versus the idea of losing data isn't even part of the conversation anymore.
So just looking at longer term reliability, you have things like graceful degradation of capacity as something that wears out as you need it, or do you have chip kill or failed chips, etc.?
We have lots of different internal architectures. The customer will always be presented with usable capacity, and each of our customers have unique asks. So we do some minor firmware modifications as appropriate based on scale of customer to support those types of things. But right now, especially in the cloud market, when we talk blast radius and things failing, you're never going to lose a bit of the data. The data is replicated somewhere always. By the time it gets to something like the 122, we've become the storage, not the active data. And so that's already replicated somewhere else. So now it's how do I shut the drive down that doesn't take the system down or force rebuilds that I don't want to have to deal with. And we've worked through all of that and incorporated it into the enterprise firmware. Yes?
For you, what are the strong points of this in-house design as well? It's around error corrections. It's because you shortcut all the paths to the different wires. What are the strong points of that?
So the in-house controller has enough back-end channels of NAND, so it's a 16-channel controller, and it has enough chip selects to go deep enough to get to 122 and even 245. As far as once we actually stack them, we have to be able to access all the bits. And then it's just, to your point, it's the ECC, it's the error correction, it's the DRAM interface. All that's built into the controller hardware, supported by the SSD firmware.
Is there a central bus running through that?
Is there what?
A central bus that's running through that?
We do actually have, today, you can see these little guys right here.
Yeah.
Those are amplifiers for the signals to the NAND, just to be able to keep signal integrity up. In the future, it's actually being embedded into our stacked package.
Oh, okay.
So we can get even more real estate for even more NAND. So we were asked to make sure and talk about customers, so we're going to drop the AI topic for just half a second, almost. I wanted to pick somebody relevant and something relevant to the local area that we're in. So in London, we are helping the hedgehog watchers. So the Zoological Institute of London was looking for a way to take their edge data center, it's 3 racks in a closet in the zoo, and enable it to do AI/monitorization of the hedgehog. And we partnered with a company, Peak AIO, to do this. Peak AIO has been a great partner of ours. They helped us with the rack space utilization, and they're a software partner that enables the consolidation of data onto our larger drives. This project, as you can see, was actually from earlier this year, so it was on the 60 terabyte drive. We're working with them now on 120 terabyte type drive solutions. So it's a local organization that we're playing nice with here. You can see 2 petabytes of storage for inferencing at the edge. And it's sitting in a closet. One of the unique things that happened with this one is, as we get into later in the presentation, we're going to start talking about cooling. The fans on the building to keep this racks cool were bothering the Chinese killdeer in their pen next door, so they had to move the deer to allow the fans to run. And so the next solution to that, of course, would be look at liquid cooling, and we'll talk about that.
See, AI mixed bag. Saving the hedgehog, annoying the deer.
And we do that by doing things like this. So this is your average, if you look at it from a GPU cluster perspective, I've got 3 racks that support 12 DGX platforms that have a whole bunch of GPUs in them. If I wanted to use hard drives to back that up and run on that with a hybrid system with SSDs and hard drives, it would take 9 racks of stored data to be able to support those GPUs. With the capabilities of the 122 terabyte drive, we can drop it down to 1 rack from 9. So getting to your ROI question, yeah, the initial cost is more, the footprint, the space, everything else starts to come into play. The power reduction, we used to say power savings right here, but really if I give them back a watt, they throw it somewhere else. So it's just a power reduction on the storage point of view. And it allows them to use those 8 extra racks for whatever they can afford to power. So Tim.
How many people are really going to be using disk drives in that situation? Shouldn't you be comparing yourself to smaller flash drives?
So that's exactly what we're trying to highlight with what Paul was talking to is the idea was you had a TLC performance tier, whether it's directly attached in the PS1010 or even in a network box, and then it's backed up by hard drives. But at 30 terabytes of hard drive and scarcity of those, people are like, well, I need storage. I might as well just go all in and go as big as I can to consolidate the rest of it, right? We're out of space, we're out of power, soon to be out of water. Anything we can do to shrink the footprint, this draws 9 watts, or 9 watts on average, 12 watts hot, compared to a hard drive that runs 10 watts, period, and physical footprint to everything is just throws the ROI off and the TCO off. So that's one of the benefits of going with something like this, and this allows us to do something like move the hedgehog servers from a building into a closet.
2.5 petabytes for a hedgehog. How long did it do it?
Look it up, it's crazy. There's a whole lot out there. So,
a lot of inferencing.
yeah. So I thought it would be fun. Supercomputers happening in St. Louis. We've got a whole bunch of friends over there. So we put together some math for our friends in St. Louis at the event. If I want to generate...
Sorry, is that your idea of fun?
Huh?
Is that your idea of fun?
Fun? Yeah.
Hedgehogs, you mean?
Hedgehogs and doing math. So if I want to store 1 exabyte of data on a 30 terabyte hard drive and I lay them end to end, I cover 3.8 miles of St. Louis. That's 3.5-inch hard drives sitting side by side just in a line down the road to get 1 exabyte of storage. To get the exact same exabyte using R122 in partnership with VAST and a few others, 1/4 mile.
Well, at least I think
So again, space is a big thing. It's important. We had another one of these that talked about how much of a baseball diamond we used up and things like that, and I'll be happy to share all that with you. It's kind of fun. But I thought since we're here, I gave you the hedgehogs, and since they're in St. Louis, we'd talk about that as well. So this is just showing exabytes take up a lot of space. So.
The ROI we're talking about though isn't the ROI of saving space in your rack and buying this extra thing. It's the ROI in terms of doing something that's useful for the business and delivering some sort of return.
Yeah.
And what I'm seeing at the moment is that very few companies are reporting any real business ROI from their AI investments.
It's like a lot of the new technologies as they come up, everybody spends, and then the reality check hits, and we start looking at the numbers to the point you're bringing up that Ben's brought up and everything like that. It's going to come down, and we're going to see it. But we've literally gotten to the point where we have people on our teams doing TCO analysis around the concrete for the floor of the building that holds the data center to look at carbon footprint and sustainability and all that kind of stuff. So it's not just about our drive, it's about how our drive enables the growth of the rest of the ecosystem. So people need data. There's a famous statue in St. Louis, a friend of mine posted on LinkedIn, he walked by. It's a head without a body. And that's currently where we are with AI. It's the head, and the body is the storage. Without the storage, the AI can't do what it needs to do because, yeah, it needs memory, and memory is there. HBM we're going to sell all day long to our partner, our parent company, SK. But at the end of the day, there's just not enough memory footprint, and memory costs 5x even what our drives cost.
So you need to ask the right questions. And I suspect one of the bottlenecks may be when the people have the right questions to ask.
Yeah. So another example of a customer and partnership where we look at the full solution stack. So we are a storage vendor, but we want to be more. We want to make sure our customers and our partners know exactly how to play well together. Verge.io is a alternative to VMware that we've partnered with that has been able to work with our 122 and our PS1010 to create the proper architecture. So now we're doing tiers of TLC and QLC, and hard drives are out there somewhere. So, good example here. I don't want to necessarily read the slide to you. I know you're going to get the slides. The data's there to be able to talk to that. So, when we think about cooling, there's basically 3 ways we can cool things right now. We can use some spinning fans. We can run water near electronics, which is always a smart thing. Or we can dip them. And I had the luxury of actually going to Montreal and talking about dipping of architectures. So we came up with, in partnership with NVIDIA, the world's first direct-to-chip cold plate SSD for the GB platform. And we've been working with companies like Hypertech, who builds servers, and Doug, who builds enclosures for, in this case, single-phase immersion. And we've even done some exploration in 2-phase immersion. So we're going to be the first provider of a drive that is warranted to be stuck in water, or in this case, food-grade lubricants that are dielectrics for electronics, if I want to use the right terminology.
If I had to choose your R&D dollars to put in there, direct-to-chip is the way to go.
So this is an example of the innovation that we did with NVIDIA to make this product work. The uniqueness of this solution is you need full contact of the cold plate to be full contact of the drive. But I've got that nice little connector sticking out the front, so if I try to stick the drive in sideways and then snap it to the cold plate, I'm going to break my connector off. So we actually designed the enclosure with NVIDIA for their GB platform reference design for the 300 series, where the cold plate's on a spring, so the drive goes in perfectly straight, spring loads out the cold plate, drive goes in, and it snaps back. So if you look at this particular drive, you'll see there's a notch to allow the cold plate to snap back. And we've chamfered the edge so that we don't scratch the cold plate because it's a soft metal. And so we need to be able to get it in and out. That satisfies 1,000 insertions and removals as required by NVIDIA to be able to put in this platform, and they had examples of it at OCP and GTC.
What metal is the cold plate?
It's various different metals. We've certified like 4 different versions. We don't own the cold plate. We work with our customers to determine which cold plates they're already using and work with it. Because there's a special, there's a special loop within the cold plate itself to make sure that the hot controller gets the most cooling, for example. But this is an example of where NVIDIA had a problem. They have all these amazing liquid-cooled servers they talked about in the GB200 series, but there were fans still in the system. And the reason the fans were there was to be able to cool our drives. And we had 15-millimeter drives. We had the fins on the drive. So in that exact same footprint, they wanted a liquid cold plate drive. So we could only put 1 cold plate. So we had to design an enclosure that actually allows cool transfer or heat removal to the back side of the drive, because we only have one side contacting. Even though they're sitting in between, there's an air gap.
Scott, I'm thinking about the 122 terabyte SSD and the 245 you're going to introduce next year. On one hand, I think, okay, this is great. But on the other hand, I think the PCI Express connection is a bit of a limiting factor if you want to get the data out. So what's your roadmap to PCI Express 6?
So there is a roadmap to 6 and 7. We're not sharing our internal design roadmap. We're sharing our public roadmap, right?
Yeah.
You guys are press. We have to be polite. But to Paul's point, to Paul's point, we have all of these technologies on the roadmap. We have Gen 5 today. We have Gen 4 today. We are looking at Gen 6. We know there's prototypes out there from others, but they are prototypes because the ecosystem isn't there. So one thing that's unique about it is when you look at PCIe even Gen 4 today, I have so many drives in the system. Even at Gen 4 speeds, you still overwhelm the internal infrastructure to deliver to the Gen 5 controller or the Gen 6 controller. You don't have enough lanes of aggregation to need the performance from the storage today. So yeah, I could say I have the world's first for certain platforms, like we do with the Gen 5, where there's only 8 drives. But on the 122 and the 245, it's not going to be 8. It's going to be 24, 32, 48 drives. You don't need Gen 6 at 245. Yeah. You can't do anything with it.
So we're looking at bringing products out that meet customer needs. So I could be the first with a Gen 6 drive that no one's going to use or buy, or I could be the first with a 122 terabyte that I can't keep on the shelf.
Yeah.
I could be the first with that Gen 6 drive, or I could have the first liquid cooled drive, cold plate drive that enables the Vera Rubin platform.
Yeah.
So I think we're making the right choices for our limited development resources to bringing out products that solve immediate customer problems. And of course, we're going to have a Gen 6. We'll have it when customers need it.
Exactly.
Yeah,
So
just
Scott, is
talking
the-
about NVIDIA. So they've come up with a systems level cooling design with you. But now if you want to go to Dell and HP and others who are doing enterprise AI, how do you take, say, a consistent form factor that they can use?
Well,
in their
that's
literacy?
exactly why this particular architecture is based on an industry standard form factor, and all the modifications to the external frame
Yeah.
that allow it to work in this architecture, along with the cold plate design, is IP that we generated but have offered
So
to all
this
those
is not
partners.
NVIDIA's IP, this is yours that you can
It's
take to
both
others.
of our IPs that we've given as part of the reference architecture for that platform, and you can take that square out of the reference platform and drop it in anywhere you want.
So Scott, is the interface now still a problem in terms of IOs and performance? Or is it not enough CPU to drive the amount of IOs you can give, or does it drive the issue? Where's the bottleneck now?
It's heavily software driven, to be quite honest. So for example, this architecture with our partner Weka,
Yep.
well, they can make our NVMe drives look like extended DRAM
Yep.
in AI systems because of the way they've rewritten how the software interacts with the interfaces of the drives. So but at the end of the day, inside the box, the limitation is the number of lanes we're driving versus the number of lanes that it can accept, because there's switching and everything else inside. So we're not the bottleneck. The rest of the server is still the bottleneck.
Are you saying that Weka use these drives in their prime appliances?
The TLC drive in the Weka platform is part of their NVMe cache extension for DRAM.
The augmented memory grid stuff?
Huh?
The augmented memory grid
Yes.
stuff?
Exactly. So I know we're running a little bit probably behind. I haven't really checked. So who remembers? Huh? We still have an hour. Okay, good. Anybody remember what the reference to 1.21?
Coming back to 1985.
So interestingly enough, that was a mind-boggling amount of power that was nuclear driven and everything like that from the movie. So the question to you, huh?
Sorry, I know.
I didn't think we had an hour.
No, you don't. No, so we don't. Put it down to a call. We're half an hour.
Okay. So we all know that A is accurate. The question is B and C and D accurate? So what are your thoughts on what does today's 1.21 gigawatts of power support in an ecosystem perspective? Is it 100,000 GPUs or 500,000 GPUs?
Yes.
No? Anybody willing?
Yes. Well, it depends which GPU.
Yeah.
So based on math, talking to customers, that'll deliver enough power to support 550,000 GPUs. Now, the interesting reason why that matters to me is because that same 550,000 GPUs needs 25 exabytes of my storage to make them work. So what used to be an 85 and a mass amount of data, which, by the way, is being powered by nuclear reactors again, because we're turning them back on in the US to satisfy data centers, supports 550,000 GPUs, and here's the math behind all that. So we've gone out and done the work. We've talked to customers. We've used industry data. Oracle and Stargate, 10 gigawatts. XAI Colossus 2 over in Tennessee. I love that one in Tennessee. They got the facility. They couldn't get the power. Tennessee refused to give it to them. So they went across the border and bought a power plant and ran lines across the border from Mississippi, I think, to be able to power their server. After they got in trouble for having 1,000 diesel generators there, creating all kinds of problems. Microsoft, of course, sitting at 600,000 plus. Meta's got their 3 million. One of our very good friends, CoreWeave, who has deployed a significant amount of Solidigm large capacity drives, at 1.3 million today and growing. So these are all what we classify as the 12 largest. And you can see based on the math associated all of the power versus number of GPUs, it's 550,000 GPUs and 25 exabytes of storage. So when I say I can do power reduction by doing higher capacity drives and smaller footprints, I'm not giving that power as a savings. They're just throwing them at the GPUs.
So Equinix say that this is all braggawatts because these have all been announced without any commitments for additional decent.
The actual power delivery is a problem, yes. And if I own stock in that business, yeah, that'd be fun too. So
So where will take OpenAI be?
So OpenAI is part of Stargate and part of the Oracle platform. It's in Microsoft. So Microsoft's AI platform is built on OpenAI because they're a software at the end of the day. So they're building custom silicon to enable their software faster.
How have you got these numbers from?
Industry data. Like you said, everything's published, whether it's legitimately serviced by Power or not. This is what they've said they're going to build. So Stargate was announced as being 10 gigawatts in each of the data centers for that many servers. CoreWeave provides data. Lambda's provided the data. Google's is public information. So this isn't anything this is just us taking the time to show people what that looks like as an aggregate. So if you have to know your customers and what your customers want to make it a successful product.
America's supporting this, and America no longer believes in global warming.
Yeah, I'm not going there. So AI, I told you I'd take a minute to get to the AI slides. So these are the 6, what used to be the simple 6 slide or segments of doing pipelining and development. So you had ingest, prep, training, fine-tuning, inference, and archive. Each of these has a data flow path and has an access point to storage. And each of them can be satisfied by our different portfolio of products. So to Paul's point, into the liquid cooling product, from data prep through training on now into inference, you need performance and you need it close by, so we call it direct attached. Then you get into the cases where your ingest and your archive are more network attached, and that's where these large drives and large storage servers are going into play, and you're doing a lot of JBOFs versus actual processing systems. But the interesting thing here is the size of data being generated by each step. This is not shrinking that data. I take petabytes, I prep it into terabytes to go into my training engines, I get gigabytes of trained data that then turns back into petabytes more data. It's all additive across the bottom line. It's not taking data and making it, because we keep the original, we play with it, we make it smaller, we do something with it, and then we throw it back out into the pond, and then everybody plays with it, and it gets bigger again. So petabytes turn into petabytes, and you generate a whole bunch of gigabytes and terabytes in between. So this is what, at the beginning of 2025, the roadmap for AI looked like. This is the 2026 coming soon version of the same thing. So it's not quite as pretty yet. We haven't had as much fun doing it. But now you have your raw data, you have your refined data, you do your checkpoint training, you throw in RAG, you have all the vectorization that you have to do. So you take a cloud-based object storage, you have to turn it into a whole bunch of vectors. The vectors are then trained, run through a RAG, re-vectorized, put back out into a blob object storage. So you can see, again, we've got it labeled here, tens of petabytes, 1 to 3 times as much data, megabytes to terabytes. So we know where the data is, and we know the different data points are, but we went from 6 easy steps, if you will, to what we have here now showing all these different transformations of data and all these different data points. And this doesn't include things like KV cache being thrown in there as much or any of the other fun things we're doing to accelerate the data consumption. This is just the steps within the AI infrastructure.
So put simply, you said earlier that inference is where it's all coming now. What's the cause of that?
So when we did it originally, we'd come in, we'd train it, we'd send it out, everybody would use a model and just get your data. And you'd get a right answer, a wrong answer, or a no answer, and you had no idea if it's right or wrong. So we said, let's do retrieval augmented generation, or RAG. So now I'm taking a trained model, running it through, doing an inference step, verifying it on itself, doing another inference step, verifying it again, and doing multiple RAG cycles, or one person's doing it here. This whole room, we could all jump on and enter the same prompt at the same time and generate 10 times more data than just what we would a year ago without things like RAG and other aspects of the regeneration models. So as we head into agentic, that's where inference. Yes, the checkpoints and the transitions and everything that you have that are right here. The more often you do RAG, the more checkpoints you have to create to be able to make sure you're using the right version of the model, and a vicious cycle. Yep. Yeah, and to your point about the cat videos, we start, all those original ugly cat videos are still out there in the big pipe being used to be inferenced into the new cat videos and things like that. So it's always...
Life cycles. I think they should be created, managed, and destroyed. Destroying is a really not good.
But we were destroying things. We put in all these things about data sovereignty, not wanting to keep things for too long because you implicate yourself. And now we want all that data back. So I have friends at Los Alamos National Labs in New Mexico that still have tape archives of all the nuclear testing they did, because we don't really want to spend a whole much more time blowing up nuclear bombs around the world, right? So they're in the active process of converting all that tape data into digital petabytes that are going to turn into exabytes of training data and inference data.
My favourite story of that one was people, one of these big facilities, recreating data off an erased hard disk because they'd erased the data, when they suddenly realised that particular cloud chamber experiment might have the sign of deep.
Yeah. Our friends at CERN, not too far away from here, right? They have a platform that when they do the hydrogen collector fires off and does its thing, they capture I got to remember the math and I might be wrong, so please don't quote me on it till I send you the slide, but like something like 2.2 million images in a blink of an eye. But because of the architecture of their system at the time they were using it, they were only able to store 1,000 of them. And now with things like this and these larger drives and this faster data access, they're collecting and saving even more of that information. So we're just making ourselves more intelligent. So when we talk about that and we talk about customers and we want to talk about how do we enable enterprise, for example, to be able to assume that they can make AI work in their systems, we started talking to everybody and said, well, what kind of hardware are you running? And they said, well, we don't own any hardware, right? It's all in the cloud. We just have to hope that once we get our data together, we know what to do with it. So we took a step back and we said, okay, we're a storage company. We have access to the storage. We have friends in the memory business, our parent company, Hynix. We have a whole bunch of server vendors that we know. Why don't we put together an ecosystem lab that allows end customers to come in and try out their wares on our platform with our partners? So take a Weka, a PKIO, something like that. And actually, we built a physical lab in Rancho Cordova to be able to do that. And so we are helping customers because they don't have the infrastructure, and we can get access to the infrastructure. High cost of building your own R&D lab, especially if you're just doing it for R&D, is unsurmountable with GB300 pricing and availability and everything like that. So we put this together so that you have an opportunity to log in from wherever you are in the world to our AI Central Lab, and you can run workloads. All day long, we register it. We actually have a wait list already. We announced this about a month and a half ago publicly, and our wait list of partners and customers is already into next year, well into next year, to support it.
So is that where Weka and Blast testing their stuff? You said they were doing models. Are they using? Did they actually buy parts from you, or?
Who? I didn't catch the name.
Blast and Weka.
Oh, they all have product. For some of the non-AI specific needing the full GPU resource solutions, they'll get product, they buy product. Weka has a white box they sell, so they're a customer, that kind of stuff. But when it comes to doing the high-level work, like, so for example, I have one proof point here. We worked with Metrum AI, a startup in the space around doing work around inference type management. This is a snapshot of a live dashboard that we did NVMe offloaded RAG. And we did a comparison between running it with data offloaded to NVMe versus solely on the DRAM footprint. And by using the PS1010 and the memory footprint for a 1 million vector data set, or 1 million token data set, 100 million, sorry, we were able to free up 57% of the DRAM resources and not lose efficiency of the return. So queries per second, more than double, even though you're using NVMe versus memory. So everybody's like, I'm running out of HBM, I need more memory. Not if you do it right. And this was only able to be done because Metrum is a startup, they don't have AI infrastructure. We had infrastructure available, we said let's get together and have some fun and prove it out. And by the way,
software engineering was required.
Yeah,
How much software engineering was required to get that?
We put about $1.5 quarter worth of combined resources between the two organizations to get it all done once we had the hardware in place.
Sorry, you use less DRAM, so you're offloading some of the DRAM content into NVMe flash and increase throughput.
Yeah.
So they must have been doing something horribly wrong.
So this particular instance is being driven by the concept of the London CCTVs around traffic. It's literally taking an open database of traffic cam video footage and doing inference on that with this platform. All the videos are stored on the NVMe, and only the checkpoints and the required absolute fast is in the memory. So that we're not taking the memory out of the system, we're freeing it for other use in the system.
So they're not been wasting the memory before,
It took longer to accomplish the same task with more expensive hardware.
Yeah, exactly. That's what I'm saying. I'm
Yeah.
being snarky, but it's sort of like, really? There must
Yeah.
be something
So
totally efficient.
that's why when you look at all of the whole ecosystem, everybody's like, storage is just a commodity, go ignore it. It's not true. We are truly becoming the backbone of this next generation of support because we're the only thing that can provide the speed and the footprint to make it all work.
They are floating the hedgehog.
Yeah, exactly. Start small, right? So, but at the end of the day, so we actually have this published. You can see we actually put it out on GitHub so people can actually download and use this and prove to themselves it works. This was version 1.0 of this architecture. We actually, at SC this same week in St. Louis, announced phase 2 results. And I don't have them with me yet because they came out literally right before the show. So we can follow up as people would like it. So what it means basically is it used to take 5 hard drives to satisfy 1 GPU with data. And so you used memory. And so that's why memory became such a bottleneck of availability, is you were offloading this into memory and then into the GPU. With things like NVMe offload, we can use 1 SSD to satisfy 8 GPUs. We have enough density in one drive that is required because each GPU can only handle so much data at a time.
How many people are using disk drives with GPUs?
That's where they started. Their architectures didn't think about it.
In the year 2025, how many people are using disk drives to feed GPUs?
More than you know.
Wow, fuck yeah.
So it's interesting because MLPerf is an open standard testing platform for figuring out what the machine learning or AI performance is of a system. And until 2025, there was no storage benchmark associated to it. It was all memory-based. So if you had hard drives versus SSDs, you didn't know it was a bottleneck because you weren't looking for it. Now that we've found the bottleneck 3 months ago, woohoo! Let's start selling. So this right here, we have a partner called Farm GPU. They're a NeoCloud that's based in Rancho Cordova by us. They put forward an MLPerf storage benchmark that set number 1 using 24 122 terabyte drives, a standard DRAM footprint, and 2 H100s. The highest performance single node AI cluster, AI server in the entire ecosystem of MLPerf. So that's the kind of things that people are starting to realize because we're starting to look at it appropriately. If you're not looking for the bottleneck, you don't know it's there. I use hard drives because I've got so much memory. I don't need to worry about it. But then you run out of memory. What's the next thing you look at? Storage.
Was it the case that as the context window for inferencing increased in size, then it became apparent that hard disk drive data delivery speeds were totally inadequate, and that drove up the NAND requirement?
That and the unavailability of the hard drives for all the archiving of the data.
The masters didn't grow their production capacity, sorry.
Yeah. So.
They wanted to raise prices instead.
They were being held by hedgehogs.
Well, and the concepts, so we have our unique technology challenges, which we overcome with 122, 245, all that kind of stuff. We can get into the device physics if you want to on that. There's also device physics on the hard drive side with the 30 terabyte and hammer and the lasers and all that kind of fun stuff. But at the end of the day, we all have data that we're generating at rates we've never thought of before, and every byte that you save on your phone that ends up in an AI model becomes about 100 times that size.
And you can KV cache offload to NAND, but you can't realistically KV cache offload to disk drive.
Nope. There's the rotational latency and the spin-up latencies are in hundreds of milliseconds. We give you 3.8 milliseconds. So.
And if you change those A100s to GB200s, how would it look then?
We're running the test now. So this is what our AI lab looks like today. This is what we've built out. So we have the B200 platforms, we have the H200 platforms, the GB300, the Rubin and Vera guys are coming. We have a huge northwest, east-south switch system set up to be able to support all the infrastructure. This is a 1 petabyte storage node of 122 terabyte drives. So there's not a single person on this planet, including someone like a Microsoft, that will go out and buy 1 petabyte of this to play. They'll buy it to deploy, but not to play. So instead of us having to sample everybody and like give all of you one in a room, you want to play with our 122? Log into our servers. We'll let you play. And then, of course, we have the high-performance PS1010 drives as well. So this is the existing infrastructure. The Metrum work was done there. The Farm GPU guys are actually helping host for us. And we have partners like Weka, Vast, and others that are doing work in this lab. And you can see coming soon, we're going to be adding more to it.
About a petabyte, and this is how you squeeze all those hedgehogs into one rack, right?
Yep.
Okay. I'm still hung up on the hedgehog.
I know, I like it.
And except the hedgehogs, do you use your own dog food and use AI channel to improve your products?
Yeah, so we actually internally, at the same time we launched this lab, we launched an internal program called the AI Demo Days, where we encouraged our engineering teams, our product management teams, our marketing teams, to find ways to use AI to make things better for the organization. Faster firmware cycles, easier debug, whatever the case may be, better layout of the next NAND devices, that kind of stuff. So we're...
You said about AI and need speed and so on. Has Solidigm considered producing its own storage plus memory SSD like Kioxia's FL6?
We have our SLC-based drive that we still sell today, the 5810. It's an SLC-based product that we are looking at refreshing, if you will. But from a storage class memory or an alternative memory perspective, that's all stuff in R&D at this point. We're not publicizing it, but we're absolutely looking at it.
So just make a really fast drive that you could use for better data storage.
Yeah, just really fast drives.
An SLC drive.
There's not a lot of alternative memories out there. There was one that was tried, right? So to be very clear, when Solidigm was spun out, the Optane family stayed with Intel and they did what they wanted to with it. We have no access to any of that IP, that kind of stuff. That's firewalled away from us. So if we wanted to engage, we'd have to resurrect it, buy it, do whatever. So we're looking at alternatives, but it's just, what is it? We're looking at whether we need to, yeah.
Do you still sell SLC drive? Do you sell any SLC drives?
Yeah.
Yeah.
Yeah, it's on our little roadmap slide that we jumped past a bit. I'll jump right back up here, because I can, just to make sure everybody sees the list. So the SLC cache drive, high performance, and then the rest of the family back here. So we do have them all. So.
Yeah, I don't sell a whole lot of them, but I get a lot of money for them.
Yeah, so this is the lab. It's going to continue to evolve. So kind of somewhat of a wrap-up. Hopefully I'm not running late or too short or whatever, but we can certainly ask your questions. Data inside the GPU server, data next to or attached to the server. We've got products and solutions that we've enabled every one of our customers to have the most effective path to closing their AI needs and other workload needs. So AI is the big thing right now, but there's all the OLTPs, there's the CDNs, everything else that's out there are satisfied by some form of a design that's related to these AI infrastructure wins, or vice versa. They won because of the work we've already done. So we have that first liquid-cooled drive. By the way, that reduces the heat issue by over 34%, so you have less power required to cool it because you're using liquid instead. We're the only product sitting on both the GB200, 300 platforms and the only drive available for the liquid-cooled platform. So that actually allows the 1U server to become a half-U server, by the way. Because you took the fan box out, which is the limiting factor, the spinning fan box out, you can re-architect the server because we liquid-cooled the drive. just as an extra data point. And you can see the growth is just absolutely insane on what we're doing with these products. On the high cap drives, as Paul mentioned, and we showed the data, we're well ahead of the game. We tend to not pre-announce products. We like to announce products with partners and say, here's why we did it, and someone who's actually buying it, not just say, look, I have something, let me wave my hand, it's really over here. You know, no magic tricks. We're actually shipping it. I showed you the 9-to-1 math. By the way, all of the top 4 Neo clouds, CoreWeave, Lambda, all those guys are using our products in their systems, either directly or through partners.
Is XAI using it?
They are buying some of our products, yes. I'm allowed to say that much.
Why don't you just publish your customer list? It's easier than us asking.
Let's see, which one of the many NDAs we have signed would you like me to talk to you about on that one?
We're under NDA, so it's fine.
We also have all the US hyperscalers are delivering solutions with our products. One of the unique things about something like Solidigm and our competitors is you're using it whether you know it or not, because they'll either buy it through a Dell and HP, they'll buy it through a Vast or a Weka or Supermicro, something like that, and it's either got our label and you have to pull it out to know it, query it to know what the drive's design tells you when you look at the component list, or they've white labeled it over the top of ours. So you're using our products today, whether you knew it or not, whether it's an AI or almost every other workload, because we're that pervasive in the market with our quality and reliability of the products we deliver.
Who built that?
Hmm?
Who built that? Because you design that, you design that, but do you build by yourself?
Mm-hmm. Anything that we would put in the market is something we would consume.
Okay.
Yeah.
I agree. But after there is somewhere a factory to do that.
The FK on it.
Yeah, as far as where are we manufacturing them?
Yes.
Yeah, so I think it was this one. No. Yeah. So this is our global footprint. Our current fab, as Paul mentioned, for the floating gate technology for the 122 is in Dalian, China. These are Solidigm specific locations, so all of the Korea locations are SK facilities, but because they're our parent company, we get direct access to their charge trap flash and their entire NAND roadmap. To Paul's point, we're also semi-agnostic, so if I need supply and I can find it elsewhere, there's always an opportunity to do other partnerships because we're our own company. And of course, we do have sales here in the UK. We have a very large firmware development team in Gdańsk, Poland. We consolidated a bunch of people from different regions in Eastern Europe. And then manufacturing-wise, design centers and manufacturing, you see we got Hinshu, we've got Dalian. Guadalajara is coming on board, is also a manufacturing facility. So building the SSD itself, not the NAND.
And with the friendship between the US and China, do you have to have some constraint on the Chinese manufacturing?
We have worked through that. We have very good party lines that my PR person over here would be glad to give you related to the US-China relations and how they impact us. But I will tell you, we get 100% of the output of what we asked for from that factory. And it's not causing us problems from a delivery perspective.
Can I answer a question that keeps going?
Yeah.
We've been hearing that there's vast demand for NAND. And Paul mentioned that for the next 3 to 5 years, demand is going to exceed supply. May I ask, why aren't you building more fabs? How long a timeline ahead of demand exceeding supply do you need before you put $2 billion into building a new fab?
But how much?
You said $2 billion.
No, $2 billion is the building. It's $18 billion for the fab.
So
18
billion to build a state-of-the-art semiconductor memory
So
fab.
you need more than a 5-year timeline of high demand. You need 10 to 20 years.
No,
yeah, go ahead.
We'll build a fab. We stopped building fabs for NAND because we were losing money. We lost money 2 years ago. We lost billions of dollars 2 years ago. Didn't make sense to go build a fab. We converted NAND capacity to HBM DRAM capacity because NAND was a dog. Now, all of a sudden, overnight, NAND is necessary to do the workloads that are happening. So eventually the industry will build new fabs. As I mentioned, our competitor, Kyosha, has clean room space. They got to get money to buy the equipment. The equipment's insanely expensive these days.
And lead times.
And the lead time, because there's only so much equipment.
And ASML can only make.
We have a clean room space in Dalian, and we've approved, the board of directors has approved investing in that because we believe in the business. But it'll be done measured. It'll be done over time, because these are huge investments. And we've all lived this movie before. We've lived this. You build it, everyone builds it, the market crashes, prices drop, you lose money, price goes up. At the end of the day, you don't build value. We got to stop that.
That can be repurposed.
What's that?
Aren't there fabs in Malaysia and Philippines which have now been somewhat abandoned that can be repurposed?
No, they don't have the power.
Yeah.
They don't have the, some of this equipment is extremely heavy. The concrete floors won't support it.
Hence the concrete earlier.
You know, yeah, we have about 5 minutes.
So I think Chris's point was, what's the point of talking about how much demand there's going to be when there isn't going to be enough flash for you to build that price to meet the demand? So apart from that, one thing I've just realised, you said all the CSPs are right at in the same week almost said to you, oh shit, we completely underestimated how much influence we're going to need, how much we're going to need to drive it. Was they all arrived at that realisation of the same week?
So
it may have not been it may have not been the exact same week. But it was in the same period of time. So there may have been a little bit of hyperbole.
I don't need to be accusing you. But why was it all? Why did they all arrive? They all hit the same realisation very.
If you look at September and the amount of data center announcements that came out just in September.
Yeah.
They all came out with multi-gigawatts worth of AI deployments. That's what's driving the ordering for next year.
It's not just we did our maths wrong, we didn't understand how the AI was. It was because their plans suddenly.
Yeah, it was all of that. Yeah.
Thank you.
So
where did I put it? Yeah.
Yeah, it was all of that. There's so much coming online, and we'll try to build more fabs over time in a responsible way, because we have a business to run, and we're going to try to solve customer problems. Yeah. And I think what Solidigm does the best of any of the storage companies out there is that we bring innovation to the market, and we look and work with a wide variety of customers, whether they're the OEMs like Dell and HP and Lenovo, whether they're the US hyperscalers or some of the neo-hyperscalers. We try to understand the problems they're facing and their customers are facing, and then go solve them together, as we did with NVIDIA.
So let me ask you a pragmatic question.
Yeah.
Let's assume you guys, and I have no reason to doubt, everything you put up on the screen, you're the leaders in this, you're the leaders in that, in all those things, great. You don't have enough supply to meet demand. Great for you guys, horrible for the rest of the world. That's not your problem.
Yeah.
What are your challenges then? I mean, look, the fact that you don't have enough supply is a great problem. It's an amazing problem to have. Any company would love to have that problem with excess demand where it is and not enough supply. So what are the challenges for Solidigm? Why do you even need to go out and do any more than what you're doing?
Because things change, and we have to have the right roadmap. We have to have the right solution for the next problem that needs to be solved.
Let me try this way. Yeah. So to answer Tim, a frog in a pot of cold water on a burner. It doesn't realize it's a problem until it's too late. Yeah. That's one thing. To your point, the cycles that we're dealing with, they've existed for 30 years. Yeah. I've been seeing these cycles happen. We're in a super cycle. We had the worst year in the history of the market right when we needed to build to satisfy the highest demand we've ever seen in the market. So we've got a disparity there. And to his point, we're going to build, everybody else is going to build. The best thing that we can do right now is innovate for tomorrow, because we have the time to focus on what's next and not just today. Today's okay. So if I don't plan properly for tomorrow, by getting out and talking to people, talking to you, talking to customers, finding out what the next big bottleneck is. I can't solve it in time.
So I get that. I accept what you're saying. I'm saying this very tongue-in-cheek, Paul.
Sure.
Why do you have a job then? Because it seems like everything. Hang on. Again, it's very tongue-in-cheek. It seems like you just have to sit back and wait for the orders to come in.
You've been talking to my CEO.
I have.
He said the exact same to me. But 2 years ago, it wasn't that way.
Yeah.
And right now, part of my job is to work with our customers and help them get through this period where we can't satisfy all the demand and look for what their future needs are to get the right solutions at the right time and to gauge how much capacity we need to add on. So,
you know what I'm saying in time.
No, of course. But no, literally, my CEO said the same thing to me. And I've had it said to me about 5 or 6 times in my 35-year career. Every super cycle. One of our CEOs told me, a monkey could sell this, why do I need you? Well, yeah, it's true.
I have no comments.
Sometimes the product sells itself. Sometimes it takes some effort. But what doesn't change is we have customers to service, and we need to do it in the best way possible to move the industry forward, to move the ecosystems forward, to find the right solutions, to understand the problems. And that's part of my team's job. I'm a head of global sales. My teams are account managers. They're not salesmen. They're account managers. They try to manage working with our customers to find optimal solutions.
That's a very well-rehearsed answer. I appreciate it very much.
I think Chris has
Could I walk away from this thinking that although there's a 3 to 5 year solid demand boom for NAND at the moment, no one NAND supplier thinks that's enough to justify writing a check for $18 billion to build a new fab?
I think everyone eventually will build fabs.
Eventually, yeah.
But you also have to look at the totality of the problem. So who's the number 1 NAND supplier in the world? Samsung. Number 3 is Hynix. Number 4 is Micron. Okay. Other than number 2, Kyocera, all of them have DRAM and NAND as part of their portfolio. DRAM is growing even faster than NAND. And as we move from HBM3 to 3E to 3.4, we destroyed capacity. So every one of those wafers. Fab capacity. Can't run more wafers through, but the wafers take longer to run. The yields are lower, especially initially, and the dies are bigger, so there's less die per wafer, even though you shrink. So as we run more HBM, we run less DDR5, and we create another bottleneck. So you need to go build another DRAM fab, okay? So you got an $18 billion DRAM fab you got to go build a NAND fab. All of a sudden, you start talking real money. So we have to make choices. And DRAM has been more profitable over longer periods of time than NAND. So those are the choices that folks are making. So the DRAM cycle will probably break first because Micron's announced a fab, Hynix has announced a fab, Samsung's announced a fab, so there'll be fabs. But maybe that actually increases the storage needs because you can't build servers because you can't get DRAM, so there was pent-up demand for storage. Now the DRAM's there, maybe you need more storage. Maybe it extends our cycle, maybe not. We're going to build a new fab eventually. Our competitors will build a new fab eventually, but it has to be done in a rational way because you have to break this cycle where you invest in new toys and never get any real value from the business. And that's been the history of memory. And I think we're changing because we went from 20 some odd DRAM companies to 3 or 4. We went from, I don't know how many NAND companies to a handful. So again, the business is at a point now where I think it could be run rationally, at least I hope so, and we could generate value for our shareholders.